Sanders Kleinfeld is Director of Publishing Technology at O'Reilly Media, where he focuses on research and development of next-generation publishing tools, workflows, and ebook content. At O'Reilly, he developed HTMLBook, a specification for authoring print and electronic book content natively in HTML5. Sanders is the author of HTML5 for Publishers. Today, he is presenting on the eBook Developers Toolbox. Please welcome Sanders Kleinfeld.
The name of this session is the eBook Developers Toolbox, and what I'm going to be doing is opening up the toolbox of tools that I use at O'Reilly Media. So a little more background on me. My title is Director of Publishing Technology, and I run what we call our tools team at O'Reilly, who are responsible for writing scripts and other forms of automation to generate, maintain ebooks, provide technical support to authors, etc. And over the years, we've built up a lot of software that we've written to help us do that. So I'm going to be talking a little bit about that today. But first, I have a couple questions for you guys. Could you raise your hands if your primary job at work is some form of ebook production, producing ebooks? I'm assuming most of you. Okay, now raise your hand if you would consider your primary job to be a coder. Oh, good. Because I do a lot of talks on similar topics, and I always like to start with this slide of what I call an inconvenient truth, which is that ebooks are made of code. And I think I am glad to see in past years when I've asked similar questions, a lot of people don't see themselves as coders. They see themselves as, book production people. But when you crack open an ebook, here's an example of an EPUB. On the left, you can see it in iBooks. This is one of O'Reilly's books. On the right, surprise, there's some code. So in this case, it's XHTML, obviously. But I think there's been a lot of denial in the industry for a while that what we're really actually doing here when we're making ebooks is doing some form of software development. So that brings me to what are the technologies of the trade? What do we use specifically in the ebook world when we talk about software development? What are we doing? So here's my acronym soup. We're doing XHTML, CSS, JS, XSLT, PDF, RDF, NCX. Wish we could get rid of that, but maybe someday. Regex, Mobi, EPUB, MathML, SVG. I'm going to be talking about some of these things today. XPath, WAF, LaTeX, Onyx, OTF, OPF, WTF. As I was putting together this slide, I realized everything is an acronym, and I don't even necessarily remember what every letter in every one of these things stands for. I think we need to get away from acronyms a little bit. But to solidify that in terms of actual tools, what are we using as well? So my guess is that most of you are using some subset of these sorts of things. So maybe you're using a lot of Adobe products like InDesign or Acrobat, most likely to produce print books and also PDFs for various purposes. If you're making Mobis for the Kindle store, you're likely using KindleGen. You may be using, at O'Reilly we use a tool a lot called Oxygen, which is a really great tool for doing all sorts of development on EPUB files. You may be using tools like CSS Lint, which is a validator for CSS. If you're not, I highly recommend it. I'm not going to talk about that today, but you may be using libraries for JavaScript like jQuery that make it easy to manipulate your HTML code. Last session talked very briefly about Sass, and I believe you talked about that yesterday, which is a preprocessor for CSS. If you're doing any sort of QA, you're probably using things like Kindle Previewer. Maybe you're using ViewSource in the web browser. If you're doing QA directly in e-readers, you may be using tools like Redium or Adobe Digital Editions. EPUB Check, obviously, for validation. If you're doing work with fonts, maybe you're using a tool called FontForge. That's my new favorite tool for editing and manipulating fonts. And a site I really like is fileformat.info, which allows you to check out Unicode code points and use different Unicode characters. So that's sort of a broad overview of what may be out there. What's in my toolbox? Specifically today, I only have about 45 minutes. So I'm going to talk about 3 things that have really helped us in terms of automation of our workflows. So 3 indispensable tools for my workflow. Number 1 is XSLT, and I'm going to do as good an overview of XSLT as I can do in about 25 minutes. Number 2, I'm going to talk a little bit about responsive ebook design and how I'm using that at O'Reilly to make our ebooks better adapt to different platforms in the ecosystem. And number 3, I'm going to talk a little bit about equations. So at O'Reilly, we've been increasingly doing more and more content that includes math, because in the data space and in programming, O'Reilly does a lot of technical books on programming topics. There's a lot more in terms of stats and math. And one of the struggles we found as we started doing more and more of that is how do we get really good equations in our ebook, and even more importantly, how do we make them accessible given some of the vagaries of the ecosystem, which I'll talk a little bit more about later. So let's dive into XSLT 101. And it's going to be a little like school. So here's a pop quiz to start off. So pop quiz number 1, XSLT is, and it's multiple choice, so you have a 1 in 4 chance of getting this right. XSLT is an acronym for Extensible Stylesheet Language Transformations. B, a programming language written in XML syntax. C, an official W3C specification. D, all of the above. Any guesses? Yeah. Whenever there's an all of the above, you know that's right? So, yes, that's true. It's all of the above. So in this case, the acronym does stand for Extensible Stylesheet Language Transformations. It uses XML syntax. There's the link there to the W3C specification, which is perhaps not the best learning tool, but is great for reference. So in a nutshell, XSLT is a tool for global programmatic markup manipulation. So that means if you want to modify in a systematic way the HTML in an EPUB, or if you're using different XML formats as part of your workflows, which a lot of publishers do, XSLT is a really excellent tool for that. So here's my example of something you might want to do with XSLT. On my left, you've got what I'm calling my frowny face HTML or XHTML. Not super semantic, using a lot of divs, using a lot of classes in places where, using a lot of deprecated attributes that would be better replaced with CSS. And on the right, you can imagine what the result could be if you ran a transformation on that, turning the divs into a section tag, taking those bolded paragraphs and actually turning them into an H1, replacing the BRs with actual paragraph tags, things like that. So whenever I talk about XSLT with people in the publishing community, their answer is always, but I use regex, or why can't I just use regular expressions for this? And the answer is, yeah, you can. So here's an example of what someone might want to do with regular expressions, converting the B tag to the M tag. So you would put in the forward slashes as your regular expression, which here is just the B tag, and then your replacement is the M tag. Anyone know what the problem with this regular expression is? This only covers the opening tag. It does not cover the closing tag. So that brings me to all the sorts of issues that can come into using regular expressions. What about closing tags? What if the B tag had an attribute on it? What if there were extra white space, which by the way is valid? It gets even more complicated than that, because attributes can be in double quotes like you see in the second example, but they can also be in single quotes. So all of a sudden your fairly simple regular expression from the previous page, to encompass these different sorts of variations, you'd more want something that looks like what you see in the bottom. I wrote this a little while ago. I don't even really know what it does anymore without having to sit. Regular expressions look like gibberish at a glance. So in and of themselves, that's one reason why I'm not fond of using them when there are other tools often. Because just to sit and parse that and understand why things are in parentheses, what stuff is escaped. You can see there's a forward slash that's being escaped. It gets really complicated really fast. And related to that, this is one of my favorite Stack Overflow posts. The link there at the bottom is really long, but I think these slides will be posted for you. And it's a long explanation about why you should not be parsing HTML or XHTML with regular expressions. And it starts, you can't parse XHTML with regex because HTML can't be parsed with regex. regex is not a tool that can be used to correctly parse HTML, blah, blah, blah. It goes on and on until like the text actually starts to like melt and mutate. But the gist of it is that one of the reasons why regex are really difficult to use with HTML is because HTML is one of these languages where you have balanced opening and closing tags. And in and of itself, regex has a really hard time with levels of nesting and stuff like that. So if you imagine like a stack, if you're going into an M tag and there's a strong tag inside, and then inside that strong tag there's a span, like regex is a really horrible tool for managing that hierarchy. So by contrast, XSLT I think is a really great tool for these sorts of things. And XSLT is different in regex than regex in that it leverages what a lot of folks call a functional paradigm. And I have this big asterisk and a lot of little text below there that a lot of people get really incensed and angry when you refer to XSLT as a functional programming language. And I'm going to ignore that for the purposes of today's conversation because I think it embodies the spirit of functional programming, even if you want to argue that this feature or that feature is not the way it should be if it were to be a functional programming language. So what do I mean when I say that it's a functional programming language? It means that basically you take inputs, you run it through a function, something that does something to the inputs and produces output. So here's sort of a simple, very simple flow. On the left, you've got some markup. And then in the middle here, what you're seeing is a very simple XSLT style sheet. And I'm going to go into that in more depth in a minute. And basically, you can see my comments, stuff happens in templates. And then on the right, you see the output. So the way I look at functional programming to get the gist of it and understand what's happening is you start with the simplest kind of function possible, which in this case is what I'm calling an identity function here. So an identity function would be one in which the input is equivalent to the output. Basically, the function reproduces the output. Reproduces the input as output, sorry. So in algebra, for example, your function f of x, 1 times x, that would be an identity function. Another one might be 0 plus x. Either way, what you end up with is x as the output. So that's the identity function in algebra. What does the identity function look like in XSLT? Looks like this. Say what? Yeah, that was my first reaction when I first started looking at it. I'm like, what is all that stuff? So I've annotated this a little bit, and I'm not going to dive too deep in this particular slide because I think the best way to understand it is to learn by doing. But basically, what's happening here is your entire style sheet goes in an XSL:style sheet tag. So that's sort of like the root element, like the equivalent in an HTML file of the HTML tag. So that's all that's saying, begin style sheet. Then for everything you want to do, there's a template. That's the equivalent of, say, a CSS selector. What are you selecting? What do you want to do stuff with? In the case of the identity style sheet, you want to select everything. So that's what that stuff in match means, get everything, attributes, elements, etc. Then the next line is an instruction, and it says copy. So because XSLT is an XML-based language, there's an opening tag and a closing tag for everything, or there's a self-closing tag. So you're copying, so you begin your copy, and so you copied the root element, and then inside is something called apply templates, which means select stuff. And here we're selecting anything, and we're closing our copy. So basically what we're doing is copying everything in the style sheet. Now, this was really, really hard for me to wrap my head around when I first did XSLT. I'm like, what's exactly happening? What is happening when you're executing this code? So what helped me to sort of learn and figure it out would be to run through the code iteratively and follow along and see what's happening as you go. So what I've got here is I've got 3 columns. Our style sheet is on the left, and then you feed XHTML into your style sheet. So what you see in the middle is the input. So we've got a body tag here that has a paragraph element inside of it that has a class of greet, and then the text hello world. So this is going to be our hello world for XSLT. And let's see what happens as we run this XHTML through the style sheet. So we start at the very beginning, and the XSL style sheet element is highlighted at the very beginning of the style sheet. As we go through, the first thing that we hit in the style sheet is XSL template match. And we just discussed that means match anything. So we've matched our body tag. So you can see in the middle that body is highlighted. Okay, so we've matched something so we can go inside our template and start doing stuff in it. So we copy. So when we hit the copy, you can see on the right, we've now copied something to output. We've copied our body tag. Okay, so now we go inside the copy and do what it says to do inside the copy. And it says apply template, select, and here we're saying select anything. So what's the next thing to select? It's our P tag inside the body. So notice here that both the opening and the closing tag is selected. We're selecting the element, not the tag. So when we hit the P, we notice again that that matches our match anything. So now we can process the P with the same template. So we hit XSL copy, and we can copy that again. So now we have two things in our output. We have a body with a P nested inside it, and we follow it in again. So we're sort of iterating as we go. And we apply templates again, and you'll see that we say, oh, select anything. So what's the next thing to select? Oh, it's the class inside the paragraph, on the paragraph element. So class equals greet. So then we can copy that because we can match it. So we match that and we copy that. We apply templates again, and what's the next thing? Well, we're out of attributes, so what's inside the P? We get the hello world text, and we match that again. We copy that, and we hit apply templates again, and there's nothing left to apply. We've gotten everything. So effectively, congratulations, we've written XSL that takes our input and reproduces it exactly. Hooray. So that brings us obviously to the next question. How do we do something useful? How do we actually transform the output? So here's where I'm going to draw an analogy with CSS. You start with your identity template, and you can then override that identity template with other more specific matching templates, just as you override rules with other rules in CSS. So on the left, for example, in CSS, you've got that asterisk, which means everything basically is going to have a font size of 10 pixels. But you then want, say, in H1 to have 20 pixels for your font size. So you add an override rule. So the equivalent in XSLT is you have your identity to do whatever you want for everything, and then you then can set aside specific rules to touch specific elements like the H1. So let's see if we can do something useful here. So what if we had a bunch of input where we had P class greet, and we wanted to convert that all to H1s? So here's what the XSL to do that would look like. We have our identity template at the top, so that's our copy everything, but then we have another template, and in that match attribute, we use a language called XPath, which is similar in concept to how you do selectors in CSS, but it's actually a more robust vocabulary, which I enjoy using. So what you're seeing here is match your P elements, and then what you can put in square brackets what's called a predicate, which is basically a test for conditions that they meet. So it's actually very similar to CSS, where you can do attribute tests like that. So here we're matching P elements that have a class of greet. And we're saying instead of copying them verbatim to the output like we do in our template above, we want to convert them to an H1 element. So let's just walk through. I'm going to walk through a little faster this time because I think you got the gist from the last time. How would this actual template work? So here again is similar input. I've added an additional paragraph here just so that you can see the difference between how P class greet is treated and how regular Ps are treated. Let's see what happens as we run the style sheet. So we start with the style sheet. First step, we hit the body element, which is the first element, and that matches our identity, but it doesn't match the second one because it's not a paragraph with the class of greet. So we match the identity, we copy it, we apply templates. So there's no attributes on body, so we go right down to the children, and the first thing we hit is our P class greet. Now here's where things change. That does match our identity template, but it matches more specifically the template that says match Ps with a class of greet. So it's going to do something different. So when it hits that, what it's going to do is this instruction, which is actually just an HTML tag. It's going to make an H1. So we made an H1. We apply templates. What's inside? The class of greet. That matches anything. It doesn't match the other template because we're on the actual attribute. So we're going to copy that class. We're going to apply templates again. We're going to hit the hello world text. Again, it matches the identity. It goes through. And then we're going to match the other P. Now, because this one doesn't have a class of greet, it doesn't match the second template. It matches the first template again. So it gets copied. We apply templates. We get the text inside. And that gets copied to the output. So you can see we've actually instituted a change in our output from the input. And we did it without regular expressions. So we didn't have to worry about the fact that there was a class on it, et cetera. All right, ready for quiz number 2? So what does this transform do? So you see that on the left we have new XSLT. At the top of that XSLT is the same identity template from before, but the section highlighted in red is the new part, where it says XSL template match strong. And here's our input XHTML. So we've got a paragraph that says learning XSLT is awesome, and we have the word XSLT in a strong element. So let's check it out and find out what happens. So we do a template match node, and we don't have a rule for p tags, so it matches the identity. So we copy it, and then we apply templates. So the first thing you'll notice is that XSLT goes in sequence. So the first thing is just the first part of the text, the learning, because that's the first child. So we hit that, and that's just regular text, and there's no template for that specifically. So we copy that over. Now we apply templates again. Here's where it gets interesting, right? Here we hit the strong element. So we have this template here that it matches, and it says XSL template match strong. And there's nothing inside it. So in XSLT, that means do nothing, because there's nothing to do. So okay, we do nothing, so we skip it. And then we move on to the next child element. Yeah, so you were very, very close. The whole thing disappears, not just the strong tag, but the text inside it. And that's a really important distinction as you're starting to do XSLT. Sometimes what you write is not what you mean. So, well, I didn't clarify exactly what I intended to do here, but that would be the result. But we again match nodes. This time we get the second part of the text, the is awesome part, and again we copy and apply templates, and we're out of stuff. So we've dropped XSLT and the strong tag. We've dropped both, and we end up with learning is awesome. So pop quiz number 3 is, what if we wanted to do exactly what you were saying, which is drop the strong tags, but leave the word XSLT, just remove the tag. And I'm going to go ahead and show you the result of that. So there's a slight difference here. So before we just had template match strong with nothing inside, we've added just one line to completely change what happens. So inside we've added the line apply templates, which means instead of do nothing, skip that element and process its children. So this time you can see we begin match strong element, then this time we select the child nodes. Actually, apply templates doesn't do attributes by default, so that's a fine distinction there. So it just gets the children elements, and then end the match strong element. So that was my really, really high-level introduction of XSLT, and I didn't touch on all the super cool things that you can do, the intermediate topics. So those include things like XPath expressions. So every match attribute that you do is going to have XPath in it. So it's basically, if you want to learn XSLT, you sort of have to learn XPath as well. But I think XPath is super cool and good to learn. Then when you're doing more advanced stuff, you're going to want to do more things than just select and copy and drop things. You're probably going to want to have conditional logic, which is something it's really hard to do in CSS, unless you're using a language like Sass to pre-process it. You know, if the markup looks like this, do this, but if it doesn't look like this, do something else. So XSL if is a simple construct to allow you to say if something is true, do that. And then where you see here, choose when otherwise is the equivalent of like an if then else in other programming languages. There's also ways to loop if you want to do repeated things. So if you want to do something every time you hit an H1, you can use something called an XSL for each, things like that. One of the features that I use a ton in XSLT is numbering and labeling. So unfortunately, as many of you know, like the e-reader ecosystem has never really been 100% up to the task of using CSS counters to do stuff. So I've found that oftentimes I have to rely on hard coding stuff into the markup in terms of numbering and things. And I don't want to have that in my source files, because all it takes is one person to rearrange a couple items in a list and you're totally screwed. So XSLT has an awesome template operation called XSL number, which allows you to number things and allows you to do, you know, regular Arabic numerals, Roman numerals, A, B, C, D, a lot of really cool stuff. And the last intermediate topic, which again I'm not going to touch on in depth today, is ways to modularize your style sheet by breaking them up into pieces and include an import. So including is basically allowing you to break things up into separate files and bring stuff in. Import does that too, but it brings in different levels of precedence. So one of the tricky things when you're starting to do a lot of stuff with XSLT is determining which template gets applied when multiple templates match. And there's a whole bunch of precedence rules around that. And XSL import is one way to set precedence rules. So this is my favorite XSLT reference book. Disclosure, it's made by the company I work for, or published by the company I work for. But I've read a lot of XSLT books. This is my favorite reference book. It is not a great learning book. I wish I could really recommend a great learning book. But like every learning book I read in the year and more that I spent struggling with XSLT was not up to the task, which is part of the reason why I put together this deck. But as a reference book, it's awesome. It's one of the few times where I feel like the book actually has better information than the internet, because XSLT is still somewhat niche, and there's not a lot of really in-depth technical detail in a lot of stuff that you'll see on Stack Overflow or different sites. Like W3 Schools has XSLT lessons, not super great. So I want to move on to my next topic, which is responsive ebook design. So about like a year and a half, 2 years ago, I wanted to learn more about responsive design for mobile, for websites, because what I was seeing is, just me personally, I was spending more and more time on the web on my phone. And I was seeing frustration with my, I was getting frustrated with the experience oftentimes, because certain sites were really well designed for my phone and other ones weren't. So I wanted to learn what tools web developers are using to do that. And I learned more and more about it, and I'm like, why is this not happening in ebooks? What can we do in ebooks? Where are we really stymied by the ecosystem and the technologies that we have at our disposal, and where can we take advantage and do better? So there are all these manifestos on the web about responsive design for websites, and a lot of people have really strong opinions. And I was Googling all around, and I could not find similar types of stuff for ebooks. So I was like, let me start digging around, find everything I can, and write up an article about it. And that's what this section is based on. So I touched on this a little bit already. What do we mean by responsive design? So this is a quote from one of the manifestos I was referring to by Ethan Marcotte, who wrote this for A List Apart, which many of you may know. It's a really amazing resource for web developers. So what he says when he's talking about responsive design for the web: rather than tailoring disconnected designs to each of an ever-increasing number of web devices, we can treat them as facets of the same experience. We can design for an optimal viewing experience, but embed standards-based technologies into our designs to make them not only more flexible, but more adaptive to the media that renders them. That's great for the web and everything, but how can we translate that same, ethos of making our ebooks adapt to different e-readers? What does it mean to say that an ebook design is responsive? So I came up with what I think are 4 good principles. Principle 1, and where I think the web is entirely different than ebooks, and every ebook developer tears their hair out about this, and every web developer doesn't get why it's so hard typesetting ebooks, is that content is split into pages. Now, I mean, there's certainly exceptions to that. iBooks has a scrolling mode, et cetera. But I think we've all sort of resigned ourselves to the fact that most of the people that read ebooks are doing so on a platform where content is split into pages. So that has to be taken into account when you're doing responsive ebook design, that your content is paginated. And as the important corollary to that, content reflows from page to page. So what you're seeing on the left and what you're seeing on the right is an excerpt from the HTML5 for Publishers book that I did, and how it renders on iPhone. That's an iPhone 5S on the left, and how it renders on iPad on the right. I think iPad 3. So same content, obviously way more text fits on the iBooks for iPad page. And you can see as a result of that, the page numbers that I've circled are different. So content reflows. Number 3, and this is an area where ebooks diverge, I think, not necessarily in concept, but in practice from the web. Obviously, anybody can go into Chrome and change settings for their browsers, but I find that people certainly do for accessibility reasons, but I don't think people spend a lot of time as they're going from one website to another tailoring the user experience by doing a lot of settings work. But the difference with ebooks is people read them for a really long time, and they read them in different environments. They read them outside at the beach, they read them at night in bed, etc. And everybody I know customizes their ebook settings. So what you're seeing here on the left and the right, user 1 is using the sepia tone in iBooks, and user 2 maybe is reading at night and likes the black background with white text. So you have to be, one thing that ebook developers have to realize is that most e-readers offer some settings that can be configured by users, and users are going to use those. And then principle 4 of responsive design, a single ebook archive for all platforms. So you're not doing responsive design if you're making 5 or 6 different EPUBs or MOBIs, et cetera. Well, you have to make an EPUB and MOBI, but if you're doing 5 or 6 different EPUBs, you're not doing responsive ebook. You're not doing a responsive ebook. You're doing 5 unresponsive ebooks. So what you want to do is you want to have a single ebook archive that works for as many platforms as possible. And clearly, there may be limits to what you can do in the ecosystem, but you can try. So those are the 4 principles. What's inside the toolbox for doing this stuff? So the first thing is CSS media queries. So just an overview of media queries for those who aren't familiar with them. Media queries encapsulate CSS rules to be applied only when certain display conditions are satisfied, such as the screen dimensions fall within a given width or height range, screen is monochrome or color, screen orientation is portrait or landscape. So this is what your general media query looks like. You've got this at media, and then you've got opening and closing brackets. So that's just the syntax skeleton. And media queries take 2 things. They take a media type, which talks about what the target platform is, and media features, which are conditionals, which may be true or false at that platform. And then inside, you put all the CSS you want. And that CSS will only be applied if the conditions in the media type and media feature are true. So media types, as defined by the W3C, there's really only a handful of them. All applied on any device, which is not a particularly useful one in most cases. Print, so when you do at media print, that's the way a lot of websites set up the style sheet that's used if you hit file print in a web browser. So often they'll convert things to black and white, et cetera. Speech, which is a media type for screen readers for accessibility purposes. And screen, which is everything else and most of what people are using most of the time. So the types themselves are fairly broad. But what's really helpful on the Kindle side, and I suspect a lot of you are really familiar with this, is that Kindle has 2 custom media types, which they've developed with the release of KF8, which I think goes back like almost 5 years now. So the one media type is AMZN-KF8, which is for any Kindle device that supports the KF8 specification, which is the latest Kindle specification sort of latest. They're doing new things with the Bookerly font, et cetera. But effectively, KF8 is still sort of the mainstream latest. And AMZN-Mobi, which I think is becoming increasingly irrelevant because more and more devices support KF8 now, and it's really old legacy devices. But they're still out there. You know, the old Kindle 2s with the white plastic casing, a lot of people still have them. So one thing, and this is taken straight from Kindle's publisher guidelines, and they're a good resource basically because they're the only official resource because Mobi is a proprietary platform. So you have to take Amazon's word for how things work or try it yourself. So this is an example where Kindle recommends that for table handling, they actually recommend this, which makes me really sad, but they do. They recommend that on the old school devices, if you have complex tables, give up and do an image instead. But for KF8, you know, you can display the more complex tables. So what you're seeing here is just really simple media queries where you basically, if you were taking this approach, which again makes me sad, you would embed in the markup both the table and an image representation of the table, and then you would turn off the display of whichever one is not relevant to the platform. So you would suppress the complex table from the old school Kindle devices that don't support complex tables, and you would suppress the image fallback on the new KF8 devices. So what do you have in terms of media features in addition to just things like AMZN KF8 and AMZN Mobi to use to further specify conditions? So there's width, height, device height. For most e-readers, the two are equivalent, and you'll see later on I actually recommend using device width and device height. But in the web world, the distinction is that width would be the width of the window, the viewport that you're actually looking through, and device width or device height would be like the actual width of the entire screen. And additionally, the W3C basically feels like this distinction should just go away and we should just be using width and height, which I think makes a lot of sense to me, but doesn't really reflect the way that e-readers work now and what they support. So in addition to width and height, there's also orientation, which is portrait or landscape, whether it's how your device is rotated, color, whether the display is color, monochrome, whether it's monochrome. So what's great about iBooks, iBooks doesn't have any custom media types, but they do support the media features of device width. So on an iPad, and you can find lots of sites on the web and documentation that'll tell you what the actual device width and height in pixels are for different devices. For Apple iPads, I'm not sure about the iPad Pro actually, but your regular standard size iPads and iPad minis as well, if you do a min device width of 768 pixels and max device width of 1024 pixels, you can get those devices. So what I've done, and this is an ongoing project that I have up in GitHub, is an EPUB called iBooks eReader Detector, which you can use, and it's got some media query logic in it that if you load this on your iBooks reader, it'll tell you what you're reading it on, whether you're on an iPhone, whether you're on an iPad, etc. This is an open source project. I would love people to contribute to it because it's hard for me just to keep these things up to date. And just a week ago, someone told me that the landscape mode 2-up view is actually a little more complicated than I thought it was. So I need to actually update this soon. But I think this is the kind of thing that we should be doing more of in the ebook world. You know, documenting what we can and cannot do around responsive design. And my third example is a media query to target both iBooks and KF8 enabled Kindle. And it's actually pretty simple. And I stole this approach from Liz Castro, who has a really great article on how she uses it to format poetry on Kindle. So if you want a style for everything that's not legacy Mobis, which would include both iBooks and KF8 enabled Kindle, you can add not, the not keyword, and you can say not old school Mobi. And that's a way that, depending on what you're trying to do, you could take one EPUB, send it to iBooks, and also run it through Kindle Gen for your Mobi and get what you want. So that's about as good as you could do in the ecosystem. So a couple more things that I want to talk about relate to pages, and I'm going to move a little faster because I'm starting to get low on time. Fragmentation properties. How do you control page breaks? You can set page break before, page break after, and page break inside to configure how things break. So if you add a page break before rule, you can say where page breaks happen before something. Page break after, set a page break after an element. Page break inside, set rules about what can happen inside. So here are the set of properties that you can pass to it, whether to always insert a page break, to avoid a page break. And then there's also left and right, which are actually really specific to page media, and where you could say add 1 or 2 page breaks to make the next page a verso or a recto page. So if you wanted to do something like force page breaks before top-level headings, you could use a page break before always to say always put a page break before H1s. If you wanted to avoid page breaks within figures, you can use avoid and say inside your figures page break inside avoid. In addition, there's oftentimes you want to do more than that. You want to say how a paragraph breaks. So if you want to set widows and orphans, you can actually do that in CSS just like you can when you're working in InDesign and setting rules or dragging things around. So I always get orphans and widows confused as to which one's the bottom of the page and which one's the top of the page. So orphans are before a page boundary and widows are after a page boundary. So if you wanted to require 3 paragraph lines to stay together at both the bottom and top of a page, you could use orphans 3 and widows 3. And there's your 3 lines. So for more on that, I'm assuming the slides are going to be posted online, but if you also Google for responsive ebook design, you'll find my article. And now I have 3 minutes left to talk about accessible math. So I'm going to go really fast. So the problem that we were having at O'Reilly is how we could produce high-quality accessible mathematical content across e-reader platforms. So obviously our first thought was MathML, which is part of the HTML5 spec, although there's a lot of controversy around all of that. But if you embed MathML in iBooks, it looks good, but start doing things like Nook. This is a Nook eInk device, and you lose all the rendering. Kindle Fire does not do great with it either. So the second option we started looking at was SVG, which is scalable vector graphics. And we wanted to do that because it's more accessible than bitmap formats, and it's also a vector base, so it scales really well, as the name would suggest. And it looked okay in iBooks again, and it looked okay in Kindle Voyage, and we were really excited this might be feasible. And then we started looking at Kindle Classic, and they just make them all disappear. And that wasn't great. That was not a good user experience. So we realized that all we could really do right now in the ecosystem is use bitmap images. So PNG, JPEG, that sort of thing. But we had 2 problems with that. How do we automate their creation, and how do we make them accessible? Because somebody who uses screen reader technology or has low vision will have trouble reading them. So I had a lot of conversations with folks at Benetech, which is a nonprofit that is trying to promote accessibility and make content available to people that need it in accessible formats. So they have a lot of great initiatives. They have an initiative called Bookshare, which makes digital books available to people who need it for free. And they asked what I needed around MathML and math equations to make things better. And they talked to a lot of other publishers too, and they came up with a web platform called MathML Cloud, where basically you can put your equation in. It has an API as well, and you can get the different results that you see here. So you can see that I've entered the Pythagorean theorem in LaTeX format, and I get a lot of things out. I get an SVG or MathML if I could ever use them someday, which is the hope, but I also get the PNG image, and most importantly, what you see in the first row is an alt text description, which writes it out in words. So then I can then throw that in an alt tag and know that screen readers will be able to read those equations out loud to people who might have trouble reading it visually. So again, that's the API. And it's open source. It's built on the MathJax node library, which is part of the MathJax project, which is the only thing that's making it possible to view equations on the web in any sort of reliable way, because most native web browsers don't have really good MathML support either. So that's what's in my toolbox. what's in your toolbox. I encourage you to think about that as you leave today and continue to add new and great tools to it. Thank you. So that's a great question. I'm going to repeat the question. The question was, aside from math, I think more generally, what can we and can't we do with SVG? And I think it depends on what readers you're targeting, and that's true of a lot of things. If you're doing stuff in iBooks pretty much exclusively, I think you're largely going to be good with SVG. SVG is a pretty complicated spec, so partial implementations abound, but my guess is for doing regular graphs and charts, you'll be able to do very well on a lot of the more modern e-readers. I think where you're going to have trouble is, like, as you can see, with e-readers like the old school Kindles and things like that. I do think that SVG is a really great way to do images because, one, you can embed text in them, so they're inherently a bit more accessible than other formats, and two, they're vector, so they're scalable, so that means that a lot of problems in the e-reader space I find happen when you've got bitmap images and you try and optimize the size for every possible screen configuration and it just doesn't work really well. SVG helps with that a bit. So I think if you're focused mostly on modern e-readers, it's probably good enough.